Welcome back, dear students, to this second video. In the last video, we went through the definition of databases, the differences between computerized and non-computerized databases, and we went further to introduce database model, where we saw that there are two categories of database model, the conceptual and the implementation. Today, we are going to look at these different models and how they work with data. First of all, we have the hierarchical model. This model organizes the data in a tree-like structure. Each child node, also known as dependent, can have only one parent node. So that is the main feature of the hierarchical model. Each child node has only one parent node, but a parent can have many child nodes. The main advantage of the hierarchical model is that the data access is quite predictable in structure, and therefore both retrieval and update can be highly optimized by database management systems. That's the main advantage of hierarchical model. Retrieval and updates of records can be highly optimized by a database management system. When we talk of optimize, it means that the time of doing such operation can be minimized. However, the main drawback of this model is that the links are hard coded into the data structure. That is, the links are permanently established and cannot be modified. That's the main disadvantage of this model. This model is applicable in content management system, file system, geographic information system. So this is an image that depicts the hierarchical model. For example, here you have R, which is the parent of these different nodes. You see that each node has exactly one parent: engine, body, chassis, which are somehow the subcomponents of a car. Then when we talk of the body, we have the roof, the hood, the high door, the left door, and so on. When we talk of the left door, we have the handle, the window, and the lock. So that is how the hierarchical model works. That is, the main component is now divided into its sub-components, and each of these child nodes are known as the records, dear students. The other model that we have is the network model. In the network model, using records and sets, this model uses one-to-many relationship approach for the data records. Multiple branches are allocated for lower level structures and branches that are then connected by multiple nodes. So in contrast to hierarchical model where a particular child node has only one parent, in network model a child node can have many parents. As advantage, this model provides an efficient way to retrieve information and organize the data so that it can be looked at multiple ways, which is different from hierarchical model. This is a viable model for planning roads, train and utility networks. So when we are for a model where we need to plan roads, train and utility networks, it is very efficient to use the network model. And that is why I said in the previous video that the data structure used in implementing this model is a graph. As main drawback, it is difficult to alter the database because information entered can alter the entire database. That's the main drawback. And the image depicting it is as we have. So others here is the record, and you see that others has as parent, customer, salespeople, and product, because others contain information about all those different other entities. That is what we have, dear students. In contrast to the model we are just from seeing. The next one is the object-oriented model. Object-oriented model is a relatively new data model and provides an outlook for the future database models. When we talk of programming, even object-oriented programming is the model of programming that is being used for developing future applications. And it's the same thing when it comes to database. An object-oriented database stores and maintains objects. That is, data is stored in the form of object. Let us look at the term associated to the object-oriented model. We have a class, which is a collection of similar objects with shared structure. That is, when we talk of structure, we're talking about the attributes and the methods. Example of a class, we can have a class student, we can have doctor, we can have engineer. So, for those of you who are already used to relational model or entity relationship model, an entity in an object can be seen as a class. That is what we have. We also have an object, which is an instance of a class. An object encapsulates data and code into a single unit, which provides data abstraction by hiding the implementation details from the user. So when I have, for example, a class student, I can have object like student number one, student number two, student number three, student number four in such a way all the different attributes that can be done on a class, an object will be able to implement it in its own way. That is what we have. We also have an attribute which is a characteristic property of an object. As example, for if you have, for example, an object student, attribute could be whole number, it could be branch, it could be series, etc. And finally, we have methods which represent the behavior of object. But basically, methods represent the real world action. That is, if I have an object, for example, student, what are the different methods? What are the different actions a student can do? A student can write an exam, a student can be present, and so on and so forth. So this is an example of an image depicting the object-oriented model, whereby you see that here I have person, which is the name of the class. Then as attributes, I have name, I have age. Then as methods, because the methods are just like function, because that's why they have those braces. I have set name. Then I have student, I have doctor, and I have engineer. Student, doctor, and engineer are just like how would I say, subclasses of the class person, because a student is a person, a doctor is a person, an engineer is a person. And as on subclasses, they also have the attributes of the superclass, which is person in this case. For those of you who might be lost with these terms I'm using, when we shall introduce object-oriented programming, all these terms shall be explained in details very well. Now, like other models, this model assumes that objects can conceptually be collected together into meaningful groups known as classes. The main advantages proposed by this model are mainly because of its inheritance property. When we talk of inheritance property, as you can see here, student is inheriting person. So I will not need to declare again the attribute name and age for student. No, because as it inherits it for person, it also has those attributes. But as it is a new model and not properly developed, it is not yet accepted by users. So that's the main drawback. Not many users are used to this model. Now, let us look at another category, the flat file model. A flat file database, first of all, is a type of database that stores data in a single table. That is, all the data we have is stored in a single table. Flat file databases are generally in plain text form, where each line holds only one record. This model is suitable for very simple databases. The table below is an example of a flat file database. So those of you who are having, for example, a table concerning the sales of a particular of your shop, and everything is just represented in one table, know that you are using a flat file model. As example, this is what we have. This particular table containing information about patients and doctors is given. So it's that all the information we have is stored only on one table, and that is what we call a flat file model. Now, let us look at the limitation of flat file model, because this is one of the model on which we pay our interest to and how to optimize this particular model. First limitation is that data is duplicated and hence stored many times, which implies wastage of disk space and increase in query time. As an example, look at, for example, this doctor with ID number one, Dr. Hyde. You see that 01, Dr. Hyde, 03. Same thing for the third record, the fourth record also. You see that we are saving the same information many times and it consumes a lot of space. Another limitation is that maintenance is difficult as every occurrence of a piece of data needs to be updated. What do you mean by that? If, for example, Dr. Hyde, which appears 3 times, let me say it's in a table that it appears 100 times, and we need to change the ID, for example, from 01 to 05, it means that we need to change it 100 times for each occurrence in the table. Another one is that more manual data entry is required, which implies a greater likelihood of errors during entry. We know the error nature of human beings. So if you have a lot of manual data to enter, and it can lead to errors. And if, for example, you have the same doctor, but at a particular instance there is a difference in ID, this can lead to an error in the whole database. Now, let us look at a particular term that is very common when it comes to flat file databases, which is called data redundancy. Data redundancy is the unnecessary duplication of data within a table. It is not a duplication of data within a table, no. It is the unnecessary duplication of data within a table. It occurs when you store the same data many times in your table. Data that is duplicated unnecessarily within a database is bad practice, as this repeated data needs to be typed in over and over again, which takes a long time and could lead to data inconsistency, which is a term we shall see, where the duplicated data values are different. As example, the information about doctor with ID 02 is entered several times, which consumes time during data entry and update if one was to do so. I think this was already explained inside the limitation of flat file databases. But luckily, the solution to the problem of redundancy in flat file databases is to create relational databases, which is the next database model we are to look at. So in the next video, dear students, we shall look at relational databases. We shall look at the key terms of relational databases. We shall move further to look at database keys, where we shall briefly explain and well elaborate the different types of keys we can have in a database, and examples will be given for you to clearly identify the different types of keys that are present in a database table. Do not forget to like, to subscribe, and to share for our community to grow, and see you in the next video, dear students.